Hey guys, welcome back once again to Study Portal 254, and today we are presenting to you internal rate of return. So we'll use this question to help us understand much about internal rate of return. So to calculate internal rate of return, this is the formula: A plus over A minus B, B minus A, whereby A is equal to lower rate, this is lower rate, then B is equal to higher rate, then A is equal to net present value of lower rate, then B is equal to net present value of higher rate. So when you want to calculate the IRR, we have to calculate the two net present value, the net present value of lower rate and the net present value of higher rate. So let's start by calculating the net present value of lower rate. So we are told that a project has the following cash inflows. Year 1, we have a cash inflow of 300. Year 2, a cash inflow of 400. Year 3, a cash inflow of 400. And year 4, a cash inflow of 900. The cost of the project is 1,500. We are required to determine whether the project is acceptable if the cost of capital is 18% using internal rate of return. Now, when we are calculating internal rate of return, we must have two rates. So already here, we have been given the cost of capital to be 18%, but we need to have two arbitrary rates. So we'll choose two rates, one to act as higher rate and one to be our low rate. Of course, we can take 18% to be our higher rate. So our higher rate, let's take 18%, then we can take 10% to be our lower rate. So we'll first start by calculating the net present value of higher rate. So I said net present value is equal to PV minus initial investment. Initial investment. So how do you calculate the PV? Present value is equal to cash inflow of year 1 divided by 1 plus R over 100 raised to power 1 plus cash inflow of year 2 over 1 plus R over 100 raised to power 2 plus cash inflow of year 3 over 1 plus R over 100 raised to power 3 plus cash inflow of year 4 divided by 1 plus R over 100 raised to power 4. Since we only have 4 years, our formula will stop at this particular point. So the first cash inflow of year 1 was 300, so it would be 300 over 1 plus. Our rate is 18. 18% is equal to 0.18 raised to power 1 plus the cash inflow of year 2 is 400. 400 divided by 1 plus 0.18 raised to power 2. Cash inflow of year 3 is also 400, so this is 400 over 1 plus 0.18 raised to power 3. Then our last cash inflow is 900. 900 over 1 plus 0.18 raised to power 4. So we'll first start by calculating the present value of the first cash inflow. The total PV is equal to 1,249.16. Remember, you want to calculate the net present value. So to get net present value, NPV is equal to PV minus initial investment. So our total PV is 1249.16 minus our initial investment was given as 1,500. So minus 1,500. Minus 1,500. we get our answer to be negative 250.84. So this is our net present value of higher rate. We'll do the same to NPV of lower rate. So ladies and gentlemen, let us calculate the net present value of lower rate. So NPV is equal to PV minus initial investment. To get PV, I said is equal to cash inflow of year 1 over 1 plus R over 100 raised to power 1 plus cash inflow of year 2 over 1 plus R over 100 raised to power 2 plus cash inflow of year 3 over 1 plus R over 100 raised to power 3, cash inflow of year 4 over 1 plus R over 100 raised to power 4. So our first cash inflow is 300. So 300 divided by 1 plus our rate. Our lower rate was 10%. So 10% is equal to 0.1 raised to power 1 plus second cash inflow is 400 over 1 plus 0.1 raised to power 2. Third is 400 over 1 plus 0.1 raised to power 3, and our last cash inflow is 900 over 1 plus 0.1 raised to power 4, 14.71. Then we add all the PVs. So the total PV here is 1,518.52. So to get the net present value is equal to PV. Our PV here is, of course, PV minus initial investment. So the total of PV here is 1,518.52 minus our initial investment was 1,500. So our NPV of lower rate is equal to 18.52. 18.52. So after this, we will now substitute to the formula of internal rate of return. So once we have calculated the two net present values, we'll substitute in the formula. I said to get internal rate of return is equal to A stands for lower rate plus the capital letter of A stands for the net present value of lower rate minus net present value of lower rate minus net present value of higher rate times the difference between higher rate and lower rate. So our lower rate was 10%, so 10 plus NPV of lower rate is 18.52 divided by 18.52 minus the NPV of higher rate was negative 250.84. Of course, we divide by the difference between higher rate. Our higher rate was 18, so 18 minus 10. So here, we will follow the BODMAS rule. We'll first start with the bracket. We'll break the bracket. So 18.52 divided by 18.52 minus negative 250.84, we get 269. 269.36. After bracket, there is no of, we have division. We'll divide our numerator and our denominator. So 18.52 divided by 269.36, we get 0.068. After division, we have multiplication. The difference between higher rate and lower rate. So 18 minus 10, we get 8. So we'll multiply 0.068 times 8. We get 0.544. After multiplication, we have addition. We add our lower rate, which was 10%. We get 10.54%. So our internal rate of return is equal to 10.54. So when we are asked to advise the management on whether to accept the project or reject the project, we need to equate our internal rate of return with the cost of capital. In this case, our cost of capital was 18%. So if our internal rate of return is greater than our cost of capital, we need to accept the project. But if our internal rate of return is less than our cost of capital, we need to reject that project. In this case, our internal rate of return was lesser than our cost of capital, which was 18%. Therefore, the project should be rejected. The project should be rejected since it has less internal rate of return.